Hello everyone, welcome to my YouTube channel Easy Chemistry. Today I would like to talk about an easiest trick to find the hybridization. Hybridization is very important topic where most of the children find it difficult to do the hybridization for a molecules. And here I come with a very simplest formula. So look here, it is number of sigma bonds plus number of lone pairs. See children, you just have to do number of sigma bonds plus number of lone pairs. On doing this simple calculation, you get a digit right. If you are getting a digit 2, then it is sp hybridization. If you are getting 3, it means sp2 hybridization. If it is 4, sp3, if it is 5, sp3d, if it is 6, sp3d2, and if it is 7, sp3d3, right? So this is the basic information that you must know to work out for the trick. And let us go for the example now. See, first and foremost, I am going for the molecule PCl5, and here phosphorus is the central atom, and you must know the number of valence electrons present in the central atom. See, phosphorus belongs to 15th group. So phosphorus has 5 valence electron, and this idea you should have, children. See, if the central atom is belonging to 13th group, it is having 3 valence electrons. If it belongs to 14th group, you will observe 4 valence electrons, 15th group 5, 16th group 6, 17th group 7, and 18th group 8 valence electrons are observed. Okay, and here we have a phosphorus, and we all know phosphorus belongs to 15th group, so it will have 5 valence electron. So those valence electrons you indicate as dots, 1, 2, 3, 4, 5, like this. These 5 dots represent the 5 valence electrons, and you have 5 Cl atoms, right? Each electron is used to make a sigma bond with each Cl atom. So one electron with one Cl, second electron with another Cl, third Cl, fourth Cl, and fifth Cl, right? This is how you will have to do. And now apply your formula. What is the formula? Number of sigma bonds plus number of lone pairs. Fine. So count the number of sigma bonds here. 1, 2, 3, 4, 5. 5 sigma bonds you have plus lone pairs. See, you don't have any lone pairs here. It is 0. So you got a digit 5. So if you are getting a digit 5, what does it mean? The compound is showing sp3d hybridization. So this is how you have to do the workout. Okay, next we will move to carbon dioxide. So which is the central element here? Carbon. So carbon belongs to our 14th group, and it will have 4 valence electrons. So you are putting 4 dots, 1, 2, 3, 4, and you have 2 oxygen atoms. And remember, each oxygen is going to take 2 electrons. One is sigma bond here, the other one is pi. Similarly, another oxygen also will take up 2 electrons, 1 sigma, 1 pi. Okay, now let us apply the formula. Number of sigma bonds plus number of lone pairs. So how many sigma bonds are there here? Only 2. And these 2 bonds are actually pi. You should not consider pi bonds. You must only consider sigma bonds. So you have 2 sigma bonds and lone pairs are 0. So you got a digit 2. If you are getting a digit 2, then what hybridization it is? It is sp hybridization. Fine? Okay. Let us move on to another example, NH4 plus, ammonium ion. So which is a central atom here? Nitrogen. Our nitrogen again belongs to 15th group. So it is having 5 valence electron. So you are putting 5 dots. 1, 2, 3, 4, 5. Okay, and you have a plus charge here. Plus means you should cancel out 1 electron. You should consider only 4 out of 5. Okay, if plus is there, subtract the electron. If minus is there, go on adding the electrons. Okay, so now you have 4 electrons left out, and you have 4 hydrogen. Each hydrogen is taking up 1 electron. So you have 4 hydrogens like this. So how many sigma bonds you have? 4, and lone pairs are 0. So you got a digit 4. 4 means what hybridization it is? sp3 hybridization. Okay. Let us move on to CO3 minus 2 ion. Okay, so which is the central atom here? Again a carbon that is belonging to a 14th group, and you have 4 valence electrons. So I am putting 4 dots, 1, 2, 3, 4, and observe here you have a charge minus 2. So you are going to add the electrons. You are going to add 2 electrons as you have minus 2 here. Okay, so these are the dots we have. Now let us show it with oxygen. So each oxygen is taking 2 electrons, already I told you in the previous example. So these 2 electrons for this oxygen and these 2 electrons for the third oxygen atom. So now count how many sigma bonds are there. This is sigma, this is sigma, this is sigma, right? So you have 3 plus 0. So you got a digit how much? 3. So if it is a 3, what hybridization it is? sp2 hybridization. Okay. So similarly you will have to do for SO3 minus 2 also. And now I am showing you ClO3 minus here. So Cl belongs to which group? Cl is belonging to our halogen group, that is 17th group, and it is having 7 valence electrons, right? I'm putting 7 dots, 1, 2, 3, 4, 5, 6, and 1 minus charge is there, no? So 1 more extra electron I'm putting here. And let us show it with oxygen. This oxygen is taking up 2 electrons. This oxygen as well is taking 2 electrons and 2 electrons. And here you have 1, 2, 3, 4, 5, 6, 7, right? And 1 more minus is there. So extra electron I'm putting here. Fine. So this is what the workout we have to do. Then let us apply the formula. How many sigma bonds are there here? 3 sigma bonds are there. And how many lone pairs are there? Definitely 1 lone pair is there. So 3 plus 1, 4. So if it is a digit 4, what hybridization? It is sp3 hybridization, right? Okay. And let us go for XeOF4. This is a very important compound, children. Let us work out hybridization for this. So here our central atom is xenon, and xenon is belonging to a 18th group. So how many valence electrons? 8 valence electrons. So let us show 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And we have 1 oxygen atom, right? So 1 oxygen atom is taking 2 electrons, and 4 fluorine atoms we have. Each fluorine is taking up 1 electron, right? So this is how we have. Okay, now let us apply the formula. Number of sigma bonds are how many? Here 1 is sigma, 1 is pi. So 1, 2, 3, 4, 5. 5 sigma bonds plus how many lone pairs? 1 lone pair we have. So apply 5 plus 1, we got a digit 6. So when you are getting a digit 6, what hybridization? It is sp3d2 hybridization. So this is how we will have to work out with the hybridization. And you have another compound XeF4 NO3 minus SO3 minus 2. This is the homework for you, children. Try it yourself. So that's all about a trick on hybridization. In the next video, I'm trying to show a trick to predict the shape or geometry of inorganic molecules based on BSc-PR theory. So that's all about the trick for today. And if you like my video, please like it and subscribe my channel. Thank you very much.